Welcome and thank you for joining today. My name is Alan Thiel with Midwest Machinery Company. I have been working with Midwest Machinery, previously Amundsen Peterson and Stevens County Implement, out of the Morris location since the summer of 1980. My background started as a service technician, but has also given me the opportunity to work in many positions throughout the company over the years. My current position of working with job codes for the service department, as well as working with training for both internal employees and customers, gives me the opportunity to work with many great people throughout central Minnesota. During this presentation, I would like to share some of the information we have experienced during the fall of 2020. This information is compiled from a list of topics and discussions spread out through the Midwest Machinery area of coverage in sales and service, including information shared by many of our customers and many of our employees. As challenging as 2020 has been in the world in general, it seems to have been a relatively good growing season for us here in West Central Minnesota. Although even here in our 17 store area, there has been a wide range of weather challenges and crop conditions, from too wet to too dry and everything in between. With that being said, every year brings its own set of challenges and solutions in farming and in the farm equipment industry. Some we have seen before, and some are either new challenges or new solutions. I will start with a list of challenges and a few solutions that were of some success in our soybean harvest for 2020. To start the year, there were a few reports of tough green beans wrapping on the reel of flex heads or draper heads. This is nothing new for some of our growers, especially those who grow seed beans and get an early start before the stems have dried down. The best answer we have for this is the addition of a flip-over reel system to your head. This addition can be a factory option on draper heads or added as a field installed option on draper heads or flex heads. The flip over action of the reel fingers does a very good job of eliminating wrapping, as well as maintaining the reel's ability to lift and feed crop to the header. Dry beans with tough green pods and stems were also a problem this year, causing some threshing or separating issues. Poor grain tank sample like this one can cause serious issues for storage or a sizable discount when selling at the elevator. These are key setting points for tough threshing separating beans that came up in our discussions. Multiple adjustments may be needed to cure this issue. Also, make one adjustment at a time and verify results, as if you make multiple adjustments, the results can worsen without knowing which one of those adjustments really caused the problem. Make small incremental adjustments, sometimes an adjustment as small as 1 millimeter on the chaffer sieve or concave, or 20 RPMs on the rotor can make a very big difference in your quality. Tighter concave versus faster rotor speed seemed to be a noticeable difference this year, according to many reports. Keeping the machine full as much as possible is another key to consistent threshing and separating, so pushing your cutting ability can make a difference. This is an important consideration when it comes time to maintain your header's cutting performance, or the time for you to trade heads and match the size of head to your combine, as too small a head or a poor cutting ability can cause you to not be able to get enough crop in to fill your combine completely. Another solution that is starting to show up in conversations is a set of Condex Revolution half-width concaves. These concaves were introduced to us at Aftermarket Expo in 2018 by John Deere as a solution for tough threshing conditions. Shown here is a coarse grain configuration with one max thresh and one max round that replaces the first concave, followed by factory round bar concaves in the second and third positions. Personally, I was intrigued by these concaves from the start, but last fall and this fall are the first years I have had the opportunity to get firsthand customer feedback on how they work here in West Central and Central Minnesota. The feedback I have received from local customers as well as technicians has all been very positive in beans as well as in corn. The key factor being more aggressive threshing early in the threshing area, which also helps the separation by getting good grain out of the material mat earlier, creating less chance to carry through the combine. These concaves are available for all STS combines and can be ordered as a factory installed option in the 2021 S Series combines. Short soybeans holding on the cutter bar and not feeding well seems to be an issue every year in one area or another. We have seen many aftermarket reel additions that seem to work or not work over the years, but the one that always has been greatly helpful is the addition of an air system to your cutting platform. Whether you are using a traditional flex head or even a draper head, it has been proven that the air system can help move that crop from the cutter bar to the auger or belt very well. Over the years, we have installed either AWS or Crary systems with very good results on both. These companies advertise crop savings at the cutter bar, which is very true. But from our experience, the biggest savings may be that even feeding into the combine, which carries all the way through the combine, reducing slugging loads and separation issues that go along with the slugs. This even crop flow will also be a big factor in the earlier discussion of settings and grain sample quality and grain losses. It does take power and fuel to run these air systems, but if header grain loss, bunching at the cutter bar, and slug feeding are causing losses, it may be a very good return on your investment. Not to mention the extra hour or more per day of combining you may be able to obtain by feeding evenly on those tough mornings and evenings. High tailings loads, plugging tailings was also mentioned by customers and technicians this year. Again, this comes down to a combination of multiple settings and possibly multiple attachments. Excess threshing speed is one of the main factors, along with concave clearance, fan speed, and chaffer and sieve openings. The issue of too much rotor speed causes severe stem breakage and overloads the cleaning system, making for a wider chaffer setting to save the grain, while overloading the sieve and tailing systems. A better setting seen this year seemed to be a tighter concave, lower rotor speed, and possibly the change to a convex concave, which helps to reduce the overthreshing. If overthreshing is not the problem, fan settings, chaffer and sieve settings are the available cures for this issue and can take several tries to get the correct combination, paying attention to making small adjustments and verify the results of those adjustments. When it comes to chaffer and sieves, there are also options to help you. In 2014, the S600 series combine started coming with a dual zone chaffer. The purpose of this rear section was to be able to close the rear section down farther, effectively forcing more air up front for earlier separation, therefore helping reduce tailings loads. Factory recommended settings is 5 millimeters open on level land and 10 millimeters open on hills. But in many cases, we have seen completely closed works very well in beans. This chaffer can be retrofitted to all S-Series combines, and from my experience is very worthwhile as the cleaning fan blast always seems to be on the low side. In beans, maybe the most helpful change as far as clean grain tank can be the addition of change from a deep tooth chaffer and sieve to a general purpose chaffer and sieve. The smaller openings, more louvers can filter material better as well as maintain that better air blast to suspend chaff out the rear of the combine. These are also good in the majority of central Minnesota corn combines, with the exception of very high yielding crops and the operator that is pushing for maximum bushels per hour. In contrast to the earlier grain sample picture, grain samples like this one from a local customer are achievable with the time and effort spent to maximize your combine and its settings. The last bean challenge we have on the list for this year is plugging of the discharge beater. This has normally been a problem associated with edible beans because of the early season and the low rotor speed used to maintain grain quality, but can also show up in a year like this in soybeans with tough stems and no early frost in most areas. For the 30-inch rotor in an S-Series combine, there is a kit available to add discharge flights to the rear of the rotor. This is easily installed and highly recommended if this issue has ever stopped your machine or if you combine edible beans. As far as corn issues this year, I would say the list of issues is much shorter for most of our customers. But as always, there are still some issues that show up. Cob in the grain tank sample seems to be our largest challenge year after year with the S-Series combine. If you do not have spacers in your separator grates to increase separator area, it would be a good start, along with making sure the concave is level. Also, the same idea applies to keeping the rotor speed low and making sure the concave is set to the correct opening to match cob size. The convex concaves have also been mentioned by customers as helping by aggressively threshing early to lessen the need for tighter and faster threshing settings. But as years go by, and we have seemed to deal with this issue every year, more and more indicators point to many of our issues coming from much farther forward in the system than most of us originally thought. Having run the X9 1100 combine this year, as well as working with many customers and factory reps over the years, we have seen definite improvements in grain tank sample quality by paying attention to all the factors forward of the rotor. Starting at the front, corn head settings like stripper plate opening, auger height, lower header speeds, and retrofitting auger floor inserts can help in many cases. In the feeder house itself, an even lower speed sprocket than the slow speed factory installed can be purchased through parts. Kits for older combines that lower the stone trap feed plate and reversing feeder house slats to have smooth edge leading can also be an improvement. Moving back to the feed accelerator, there are options of swept back or smooth wear plates that can cause less kernel damage while still providing good feeding action of material to the rotor. Those are several items that have been shown to make improvements before getting to the rotor and its settings required there for threshing and separation. This fall has obviously been less of a problem because of the lower grain moisture, better maturity, and higher quality corn we are harvesting. But we have still seen some poor conditions in this year. With that being said, I did see the cleanest corn sample I have ever seen in an S-Series combine this year. This was an S670 combine with a 12-row, 22-inch corn head and a fixed feeder house drive. Because of the fixed drive, we had to change the gears around on the corn head to speed up the units, which results in a auger running slow, feeder house running slow, and the row units still running fast enough for the Stockmaster to do a good job at 4+ miles per hour ground speed. Threshing and separation of this combine were very good, while noticing many near whole cobs at the rear of the combine. No noticeable grain loss, very low tailings levels, and a very clean grain sample with minimal fines and nearly zero broken pieces of cob in the tank. After watching this combine with the slower speeds up front, I am convinced some of the information we have witnessed over the past seasons about grain sample quality definitely needing to start and concentrate at the front of our machines is worth the time to discuss. We always hope for drier than normal grain sample, but it can also cause a few issues from time to time, such as fines in the grain sample or a specific cob being still too spongy, causing the cob to split before releasing kernels. Every year, there seems to be at least one or two corn varieties, maturities, or stressed fields that cause this nearly impossible threshing problem. This year was no exception. The problem is recognizing this issue and finding out where in the process the problem is occurring. The best investigative method is to use a power shutdown, which gives you the opportunity to examine the crop on its entire route from the head to the discharge of the combine. Many customers have mastered this, and many still struggle, but the power shutdown is a very helpful tool. If you are unsure the steps involved, a good place to go is the John Deere App Store and download the Go Harvest app. This app contains a complete guide to adjustments as well as the step-by-step process of doing a power shutdown. Or if you are still having problems with this, contact us at Midwest Machinery and we will help you find the correct information. After using power shutdown and exhausting all the other procedures we have just discussed, you may still have an issue where a particular cob is just too spongy to allow good threshing without the cob exploding into small pieces. This year, I talked with one customer who had exactly this problem with corn that was only 21% moisture, but the cob was so spongy and split so easily, it was nearly impossible to separate all the kernels. Going through every available option and still having loss levels unacceptable, he called his seed rep, who said he had heard the same comment from another customer. His decision was to leave the field and return at a later date. When he returned, the corn had dried to 18.5%, and the cob had improved enough to allow improved threshing. Although his loss levels were still higher than desired, but much better and at a level that could be accepted for a very tough situation. I guess sometimes Mother Nature throws us a curve and we need to adapt, as some issues cannot always be eliminated by our machine or by the settings we put in our machine. High trash intake and separation issues are more of what I expected to see in a year like this, and it was present in many cases. Deck plate spacing and proper corn head or feeder house speed are the two common settings to work with on this issue. Although I think one of the most common issues we have seen over the past few years for this problem is worn stock rolls. Many times we don't even realize the amount of wear on our stock rolls, especially with a chopping head, because it generally In general, it strips stalks down through the head very well, using the extra pull of the chopping knives as well as the stalk rolls themselves. Or in many cases, we just overspeed our head anyway to make sure we are running fast enough to do a good job of chopping. But if you are looking to replace stalk rolls, there are options that have different fits for your normal crop situation. A chart like the one shown here is available in the sales manual with different stalk rolls and their strong points to help you in your decision on which one to install. Considerations like power consumption, residue sizing, trash intake, and normally wet or dry stalks are part of the discussion. When trash intake cannot be eliminated, the issue normally becomes loss of crop out the rotor. The best option I have seen to help with this issue is to install one heavy-duty separator grate in the front grate position, along with 4 interrupter bars or more spaced throughout the grate. This is a cast separator grate with bolt-in bars, originally produced for rice, but works well in other heavy crop situations, adding an interruption to the crop flow for better separation. With the second option being faster rotor speed, which causes other problems. The heavy-duty grate with interrupter bars can be a very worthwhile investment. Yield monitor accuracy also never seems to completely leave our discussions. The introduction of active yield has replaced the need for calibration of the yield system. Using the mass flow sensors and a set of weigh pads in the grain tank, the system adds a calibration automatically when the grain tank is emptied and then refilled. There are several criteria that need to be met, such as not being on a side hill, having a consistent input, being completely emptied, and then refilled beyond 6,600 pounds. Once these have been met, a calibration will be entered into the system, comparing the mass flow estimate with the active yield estimate. John Deere's best practice says the system should have all previous loads deleted when starting a new crop and let the system work until several calibrations have been registered. While doing this, some loads will be eliminated from the calibration process because of the issues I mentioned, but throughout the day, many loads will be captured. Then a simple correction of a percentage over or under can be entered to match scale weights. This year, I heard mixed results on accuracy of the system. From one customer saying all crops were within 1% of what scale tickets to yield monitor, to another customer that had to enter an 11% additive to get good readings. That being said, the simple correction of a percentage over or under is still easier than several manual loads of calibration. The other thing to remember with this system is that while it may vary from load to load, it is really more accurate when looking at field by field totals on a large scale. Tillage this year seemed to focus around residue management, soil compaction from previous wet years, and a tillage angle as it relates to high-speed planting. A relatively new tillage piece for us this year was a 2680H high-performance disc. This machine features 2 gangs of individually mounted discs with 10-inch spacing, with the front rank being at a 17-degree angle and the rear rank being at a 14-degree angle and a working depth up to 6 inches. This is a very aggressive machine. The rear attachment of a cage roller, a spring roller, or a rubber roller makes it customizable for your primary use. This is a residue management tool capable of covering a large number of acres in a short time with tillage speeds of 10 plus miles per hour. This picture shows a one-pass operation of 5.5-inch deep tillage at 9 miles per hour. This field is irrigated corn in 22-inch rows and a very heavy residue load, harvested with a John Deere Stockmaster chopping corn head. As you can see in the picture, it did a very good job of mixing residue and soil in dry conditions with fluffy stalks. For this customer, this is a great residue management pass at a lower cost per acre than conventional tillage, in a situation where soil compaction is not an issue. In other situations where soil compaction is an issue, customers are running this tool as a preliminary pass to bury residue before a deeper tillage tool, or in some cases as a secondary pass after a ripper to manage more residue and create a more level soil profile for next season. Overall impression of the 2680 was very good this fall, although we did witness some issues late in the year in wet conditions where the machine had some plugging limitations. A little more conventional normal tillage practice for this area is a 2730 ripper. Also doing a very good job of residue management as well as ripping at a depth of 10 inches in this field where soil compaction is a concern. The 26-inch front disc blades cut and bury residue very well while the ripper loosens compacted soil. The rear conditioner helps level off the ridges, and the optional knife edge rolling basket levels and breaks up clods for more consistent surface. Over the past several years, the 2730 has been found to be a very effective tool in nearly all conditions and situations, as well as being a very trouble-free tillage machine. With John Deere TrueSet machine control, the ability to make depth adjustments from the cab or run prescription tillage can be a game-changing tillage system by adding the ability to do more or less aggressive tillage throughout the field where needed and possibly reduce costs by doing that. Then Mother Nature threw us another curveball, and we have this on October 20th. Pulling a deep tillage tool in these conditions can prove to be very challenging, although as seen here, the wetter residue conditions make for a very good job of covering residue if you can find the traction needed to pull this machine. In this case, the 2730 ripper does a very good job, where on the other hand, the 2680 would not have been a very good choice on this day. With the move to higher speed planting over the last few years, I had several customers call me this fall to discuss thoughts on what should I be thinking about this fall as it relates to my high-speed planter. This is a very good question and one that has always been around, not only for high-speed operations, but for any planter accuracy. Obviously, residue management and soil compaction are going to be your main concerns. But I believe when it comes to planting into this ground in the spring, ride quality of your planter also becomes an increasingly important piece of the conversation for all planters. With ride quality in mind, I think the main part of the conversation that is new for some customers is the angle of the tillage pass. What we have seen over the past few years is many people changing to a much less angle of tillage in the fall and very little or 0-degree angle in the spring. All of this is dependent on what type of tillage you are doing in both seasons. But the key to remember is the ride quality is the key for traditional planters without trench delivery systems. And ground contact is the key for high-speed planters with trench delivery systems. Ridges and wheel tracks at an angle across the field will cause both problems. So less angle leaves less ridges to cross, making for better ride quality and more consistent downforce settings to obtain consistent ground contact at high speeds. From our observations with the ExactEmerge planner over the last few years, the final pass in the spring being done at a 0-degree angle from planning makes the most difference for ride quality and consistent ground contact at high speeds. To summarize, a straighter tillage angle creates less row unit bounce, while also giving the hydraulic downforce the best chance to keep the correct pressure on the correct rows at all times. I hope this information can be of some help to you in the future, and thank you for joining us today.